Hello, this is Nicholas Constantinou from the coordinating team of SoFiN, a Horizon Europe project that started back in December 2022. It is already in its final period and expected to end in November 2026. The technical innovation of the project involves a modular software-controlled platform which has been developed for sensing fiber networks to monitor large infrastructures. The developments include a new hardware platform interacting seamlessly with the sensor elements, the newly developed machine learning algorithms, the cloud platform, and the digital twin. All these key developments working together bring an innovative multisensing system to monitor structural health. The system will be validated in infrastructures like monitoring telecommunication, power lines, and water supply networks. It is really great to now have our month 37 physical consortium meeting in parallel with the initiation of the first use case validation. This is an important milestone where the SoFiN concept is demonstrated as a full system of all components connected to monitor a telecom network. Therefore, the SoFiN innovation overall provides a solution where large infrastructures can be remotely monitored continuously, immediately alert as soon as an event is sensed, and even indicate the location of the issue, like for example, the location of a leakage along an underground water pipe network.
I am Angelo and I am a research scientist at NKT Photonics. My company specializes in the development and commercialization of fiber-based lasers. In particular, we have a long history of developing single wavelength lasers, especially at the 1550 nanometers for the remote sensing industry. Our role in SoFiN is to develop light sources to power the interrogation process of FBG sensors in the fibers under test. And in particular, we are developing both a single wavelength laser and a frequency comb, with the frequency comb representing maybe a lower TRL project, because we believe that it's important to push this industry farther into the future.
My name is Christos Giordano. I'm working as a technical engineer in Nicosia District Local Government Organization, and we are going to install some fiber optics in test rig so that in the SoFiN project we're going to find the leaks in our system.
I'm Esther. I'm a research assistant at Friedrich Alexander University in Erlangen-Nuremberg. Within SoFiN, we are focusing on the investigation of novel sensor types, for example, pi-phase-shifted FBG. Therefore, we first clarify the specifications the sensor elements need to be used with the SoFiN interrogator. Then, in the next step, we order them and we parameterize and characterize the sensor elements in our lab. It's really great to be part of the SoFiN project, because I do not only meet other people and learn a lot about optical fiber sensing, but I was also able to finish my PhD within the SoFiN project.
My name is André Sandmann from Atran in Meiningen in Germany. Atran is a provider of networking systems, so optical fiber networking systems, solutions for infrastructure assurance and precision timing solutions. In SoFiN, Atran is developing a multi-purpose fiber optic interrogator in order to detect events that occur in the vicinity of the fibers, such as temperature changes, vibrations, and acoustic signals. This interrogator is combining information from the time and frequency domain in order to interrogate various types of sensors next to standard single mode fibers and creating based sensors in order to measure events on different timescales. And this also gives a high flexibility of the interrogator. And this will enable operators and owners of infrastructure to detect events in the vicinity that can affect day-to-day operations, might impact the fiber. So we are looking at detecting events that are critical for the infrastructure, and we want to warn the operator before damage occurs. My name is Roman. I am a postdoc in Denmark Technical University. My work in SoFiN is mostly related with machine learning way to detect and to distinguish the events which we want to sense. It turns that mostly this work is a theoretical one. I'm doing a connection between the events like temperature or vibration, which we're gonna sense, and the measured signal we have, optical signal, and this connection coming through the physics. So based on this physics, we are able to build architecture of machine learning, able to distinguish these events. The second part of my work is mostly technical one, is related with building a program which is able to handle the new coming data, to process the data, send it to the cloud and stuff like that. So it's quite interesting work related with interaction with quite smart and interesting people.
Yeah, hi, I'm Lukas. I'm a research assistant at Friedrich Alexander University in Erlangen, Germany. And I actually just started as a research assistant this year in January. And SoFiN project is one of the first projects I'm part of as a research assistant at this university. So we are mostly in SoFiN project working on digitalization of optical fiber sensing. So for example, we're working on a digital twin of optical fibers. And so basically we are making a digital copy of all the sensors that we have in our research network. And then we can later on do simulations and also other calculations with those fibers that we have in the system.
My name is Hui from Technical University of Denmark. I'm currently enrolled in SoFiN projects, mainly focused on developing a numeric model and digital signal processing for optical fiber sensing system. The main goal is to establish a simulation framework that can accurately generate the backscattering signal. It would be integrated into the digital twin system that supports the real-time analysis and intelligent control.
Yorgos Gerontidis from CSIRIC in the software department. And my role in SoFiN is working on the cloud platform. We need to design and develop the architecture, the infrastructure, and the web interface to visualize the data. A lot of great work has been done in general in SoFiN, reducing the data at the edge. And our goal for the cloud platform is collect it and visualize it for the stakeholders to essentially have a list of clear indicators what has been sensed with the fibers.
My name is Konstantin. I work in Tele2 Estonia in the Data Transmission Network Department, responsible for our optical transmission networks based on DWDM technology. In the SoFiN, we are responsible for providing the testing infrastructure, responsible for connecting the prototype of the testing equipment, for preparing the optical POPs, and assisting in further testing.
My name is Marko Tikas and I'm from Tele2. Tele2 is the best mobile operator in Estonia, Baltics, Scandinavia and all the world. This year in December it was Tele2's turn to organize the SoFiN meeting in Tallinn, Estonia. It was really nice to welcome people, researchers from all around Europe. Tele2 has been part of the project from the very beginning, and now we're in a stage where we actually have a prototype which we deployed on our network, on our optical network. And now we're able to see the opportunities or the features that the product can produce. So I have been part of the project from the very beginning. First 3 years we were researching the equipment, and it's finally really nice to see the working prototype, what we deployed on Tele2's network. In upcoming year we are going to run lots of different tests with different use cases, and I'm really excited to see what the equipment is able to produce.
And briefly to conclude, on behalf of the SoFiN consortium, I would like to thank the European Commission for supporting this project, and of course all colleagues for an amazing collaboration.